Bismillahirrahmanirrahim. Today's lecture is about capacity of multiple input and multiple output systems. This is lecture number 25 for the week 11 of Advanced Wireless Communication online course. So the capacity of MIMO system is defined as the maximum amount of information or the maximum amount of the data rate that can be transferred on a multiple input, multiple output systems. So we will define the capacity of the system which have been basically used for SPD decomposition. So we will find the capacity of the systems in which the channel matrices of the MIMO system are decomposed through the SVD mechanism. So we know that the received signal at the parallel MIMO channels decomposed by SVD is given by sigma I xi plus wi. This is the Gaussian random variable with variance sigma square, and sigma is the gain of the channel. The xi is the expected value of xi square, is given by the total power transmitted into the symbols. The signal to noise ratio is given by sigma I square pi by sigma square of each channel. So this is the power of the ith transmitted symbols. So as we have shown previously in the previous lecture of SVD decomposition of MIMO systems, we have parallel channels. So for the ith channels, SNRI would be given by sigma I square into pi divided by sigma square, where I goes from 1 to t. So this SNRI can be used to find out the Shannon capacity rate of the individual channel. So that capacity rate of the individual channel is given by log of 2 into 1 plus sigma square pi by sigma square, which is the variance of noise. This is the variance of the parallel channel, individual parallel channel. So as we have multiple T parallel channels, so the total sum of all the channel rates would give you the maximum capacity or the maximum rate that can be transferred by the MIMO system. So sum rate would be equal to the sum of log of 2 into 1 plus SNI for all the channels ranging from 1 to T. The only problem here is that the total power limited is equal to the total transmit power, which is equal to the sum of powers across each individual channels. So the capacity of the MIMO channel is defined by the maximum of the sum rate. So we can have variable sum rate that would depend upon the amount of power we put into the different channels. So that is given by this constraint. So this complete problem with the objective function, which is to maximize the sum rate across all the channels, and subject to this constraint. This whole problem is basically a constraint optimization problem, because we need to optimize this objective function with this constraint. Okay, so we will solve this problem with the help of Lagrange multipliers. The formula for the Lagrange multipliers is that you put the objective function and then you add Lagrange multiplier and multiply it with the constraint. We know that this is the constraint. If you put this side on this side, it would be p minus sum of pi from t is equal to 1 to t. So let's differentiate the above and put it equal to 0 to maximize. So if we differentiate this function, it would be giving you sigma I square by sigma square to 1 plus sigma I pi by sigma square plus lambda into 0 minus 1, because sum of pi is equal to 1, that is equal to 0. From here you find the multiplier lambda that is given by this equation. So 1 over lambda is equal to pi plus sigma square over sigma I square, or pi would be equal to 1 over lambda minus sigma square over sigma I square. The power plus plus means that we have a positive value. 1 minus sigma square over sigma I square. If 1 over lambda minus is greater than 0, this is greater than 0, then that would be the value. Otherwise, if it is less than 0, pi would be equal to 0. So that is pi. What does this mean? This lambda is the Lagrange multiplier. This is the constraint. If we put the value of pi here, that all these values should be equal to p. Lagrange multiplier can be obtained by solving this equation. So Lagrange multiplier can be found out if we use this equation. You just have to put the value of pi here. This optimum algorithm to achieve the capacity or maximum rate of the MIMO system is termed as water filling L. Thank you.